Located at the University of California, San Diego, researchers at the California Institute for Telecommunications and Information Technology, CalIT2, have been working on a novel 3D user interface that will allow both novice and experienced users to quickly and easily build 3D models of architectural designs.
So here we are in the Star Cave at CalIT2. The Star Cave is a 15-screen rear-projected virtual environment with 34 HD projectors, passive stereo, and we have an optical tracking system. This handheld joystick is part of it, which is based on 4 cameras that are located at the top of the walls, and they look down into the space and track the joystick and also my hat.
So today we're working on the competition for the 3D UI contest, and I was attempting to build the Walt Disney World castle, the Magic Castle, the Cinderella Castle. So in 15 minutes.
The software we're going to be using here is called CaveCAD, and it's a software interface that we wrote here at CalIT2 that enables you to, with a wand and a head tracker, monitor both where you're looking and where you're pointing so that you can stand inside of a floor plan and raise up columns and put on beams and insert walls and see views and apply textures and materials in real time in full scale space, so that you can see the consequence of design immediately.
The team designed an interface specifically for this unique 3D projection environment that allows new users to quickly begin building instead of focusing on learning non-intuitive commands.
So traditionally, these 3D modeling tools are used at the desktop, where someone uses a computer with mouse and keyboard and one of the various available commercial products to build a 3D model. That takes time, and it takes a skilled designer to do that. What we can do here in these 3D environments is that we can allow the user to use the system more naturally. So we hypothesize that it's going to be easier for a user to learn how to use these 3D systems when you don't have to learn complicated combinations of keyboard presses and mouse clicks and mouse drags.
As we were developing ideas of what this interface should be, we of course were working with people from multiple disciplines. And our universal theme was that it had to be intuitive to use. We began with the typical drop-down menus, which are in fact a legacy of a computer desktop screen. And what was happening is those menus were in the way of our design space. And so one of our team brilliantly combined them into a cube. Smart cube that could spin and be loaded with numerous different layers of modes and functions, and then palettes of materials.
We've made a few novel developments that are specific to the CAD modeling tool. One thing is, for instance, the user interface that we can see back behind me. There are these sphere-shaped icons which have the benefit of being as wide as they are tall. So you always have, with a device like the one I'm holding, it's always as easy or hard to touch them, whether you come from a horizontal or vertical direction.
According to Schultz, the implementation of the user interface is novel, but based on a combination of existing ideas.
One difficulty in these cave environments is that there's no dedicated direction or location for things that would indicate a mode, for instance, so we're trying to do that modeless. We do have the interface, which though we can move to any place in the environment, so that we can build something over here and have our interface with us, or we can go over there and have our interface with us. And that's certainly one of the important capabilities of this interface, to allow for 3D modeling.
For the 3D UI competition, both novice and expert users were asked to build the iconic Cinderella Castle at Walt Disney World using the CalIT2 developed CaveCAD system. Utilizing footage whose speed has been increased, we can see the results of the novice user here.
Training novices is quite difficult. The concepts that go behind 3D modeling are more complicated than can really easily be expressed in a really simple user interface. We're working on that. We're trying to make it very accessible.
Designer Kathleen Hughes, also an advanced user of the system, is shown here attempting the same build, utilizing the same software and again, the 15-minute time limit. Going forward, the CalIT2 team at UC San Diego aims to make CaveCAD cleaner and easier to use, particularly with the participation of architects and engineers looking for a unique way to visualize their creations and explore them virtually.
In the prototypes we're building, we're not aspiring to implement all the functionality of products that are commercially available, but we're aspiring to at least creating a tool that can allow doing things the way that designers do them at the desktop in novel ways that are easier to learn, more efficient, and also probably more intuitive. And that's what we're aiming at.